Video 7-2, Nomenclature for ionic compounds, nomenclature for molecular compounds, writing formulas for molecular compounds, nomenclature for acids, and writing formulas for acids. Okay, so, nomenclature. First of all, what does nomenclature mean? Nomenclature is just simply the naming rules. Okay, so, how do you name an ionic compound? Okay, pretty simple. Figure out that it is an ionic compound. Look at the formula, metal, nonmetal, or you'll see a polyatomic ion present. Okay. Second thing, the cation. It's always the first ion. If it has a subscript, that means you have more than one of them, but the first ion you see is the cation. Okay. Then second thing, the rest of the ion or rest of the compound must be the anion. Okay, and again, you don't care how many are present. Just identify them by sight and know what their names are. Okay, so how do you name it? Name the cation, name the anion. Do not use the words ion in there. Okay, so just name the cation, name the anion, and that's the name of the compound. Okay. Now, if you notice that the ion is a transition metal, okay, or one with multiple oxidation states, okay, you have to name it according to the proper name. So you have to be able to figure out what charge does this ion have. Okay, work backwards to figure out what the charge is. Remember, okay, if it's XAYB, that means B was the charge for that one, A was the charge for that one. Okay, and you have to be able to recognize your polyatomic ions by sight. Okay, so name these compounds. Okay, and pause, come back, and check your answers. Okay, so the first one, the break between the cation and the anion has to be after the first element, so it's going to be right there. So your first element, there's 3 of these CAs. We don't care how many though. We just call it calcium because it's a calcium ion. PO4, we don't care about the 2 out there. We just know that PO4 is phosphate. Okay, second one, the break is between the NH4. Okay, if you see parentheses, that means a polyatomic ion, so everything has to stay together. So the break's right there. So NH4 is ammonium. Okay, and SO3 is not fate, but sulfite. Okay, sulfate was SO4. Now the break here on the next one is after the Ni. So this is nickel. Okay, and C2H3O2, this is acetate. Okay, but remember nickel, there's 2 of them. So which nickel charge is it? Nickel is either 2 plus or 3 plus. So remember this 2 came from that ion there. So that means this must be nickel 2. Or you could have called it nickel 2. The nickel 2 plus ion is nickel-us. Okay, nickel 2 acetate or nickel-us acetate. Okay, next one. Break there is iron. CO3 is carbonate. Again, make sure you can recognize your ions even when you don't see the charges. Okay, now, I can't just call it iron carbonate because, again, this has multiple states. Okay, the 3 did not come from up there because the CO3 is the whole carbonate. Okay, so the subscript for this is actually 1, but there is no iron 1. It's either 2 plus or 3 plus. Okay, now carbonate is 2 minus, and there's only 1 iron. So that means the charge of the iron must be the same as the carbonate, but just the opposite charge. Okay, so in other words, this must be iron 2 or ferrous. Okay, so you have to know your charges. Okay, this one here, the break is between the Cu and the Cl. So Cu is copper, okay, and Cl is just simply chloride. Okay, but again, you need to know the charge. So that 2 came from up here, so it's copper 2, okay, or cupric chloride. Okay, notice the anions, you always know what the charge is, so you don't have to indicate anything about it. From the name, you should be able to figure out the charge. Okay, now next one is sodium. Okay, and you see the O, and it looks like, oh, that's just oxide. Okay, but the formula for sodium oxide, if I told you it was sodium oxide, you would write the formula saying, okay, sodium's column 1, Na1 plus, oxide is oxygen, column 6, that's 2 minus. So the formula for sodium oxide is Na2O. This is Na2O2, so this cannot be sodium oxide. Okay. This 2 actually came from up there, and that means it's O2, 2 minus, which was the peroxide. Okay. Lead and oxygen, so we have lead and oxide. Okay. And it looks like, oh, I need lead as another one with multiple charges, so the 2 came from up there, so you'd say it was lead 2. But if I told you it was lead 2 oxide, and you'd say, oh, that's Pb2 plus and oxide O2 minus. So lead 2 oxide would just be PbO. This is PbO2. Okay, so what does that mean? Since you know oxide has to be 2 of them, has to be 2 minus, there's 2 of these. So this must be lead 4. Okay, or plumbic oxide. Okay, so double check. Okay. Nomenclature for molecular compounds. Okay. To name a binary molecular compound. Binary just means there are 2 elements. Doesn't mean 2 atoms. Okay. 2 atoms is diatomic. Binary means 2 elements. Okay. First of all, you have to know it's a molecular compound. How do you know that? Look at the formula. It has to be a nonmetal bonded to a nonmetal. Okay. Now, molecular compounds are super simple to name. Okay. All you do, look at the formula, name the first element. If there's more than one of them, use a prefix. Okay. If there's only one of them, you don't use any prefix. Okay. Do not use the prefix mono in front of the first element. Okay. Name the second element. Change the ending to "ide." Okay. And you must use the prefix. So even if there's only one of the elements, you have to use mono or mon in front of it. Okay. So let's try a couple. Okay. Simple. So make sure you know that these are molecular compounds. Non-metal, 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 non-metal with a non-metal, 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 non-metal. Okay. So always name the first element. The first one is sulfur. Okay. Next one is phosphorus. Okay. Next one is phosphorus again. Okay. Next one is nitrogen. Next one is hydrogen. Okay, we don't change the names of the first elements ever. Now, if you have more than one of them, you need to use a prefix. Only one, so no prefix. One. Okay, only one, only one. Oh, there's 4 down here, so we need to use a prefix. The prefix for 4 things is tetra. Okay, only one of them on this one, so no prefix. There's 2 of them on this one, on the water. So this is dihydrogen. Okay. Second element must have a prefix. So that one has 2. And the prefix for 2 is di, not bi. Okay. And then oxygen, you have to change the ending. So it's oxide. Everything has to end in "ide. And don't forget, drop a bunch of the name of the element also. Okay. Next one is chlorine. There's 5 of them, so it is pent. Okay, we dropped the A, it's not penta, so it's just pent. Oops, sorry, it is penta. Okay, if there's a vowel in front, you don't use the A. So, next one, there's 10 of them. There's dec. but because it's oxygen, it's a vowel, we don't call it decaoxide, we just call it dec oxide. Okay. Nitrogen, there's one mono, but a vowel, so you don't use the O, so it's just monoxide. Okay. Another single oxygen here on this one, so it's also monoxide. Okay. So sulfur dioxide, phosphorus pentachloride, tetraphosphorus decoxide, nitrogen monoxide, dihydrogen monoxide. Okay. Chemical name for water. Okay. Writing formulas for molecular compounds. Super simple. Okay. You have the name, write down the first element. If there's a prefix, that becomes a subscript. Okay. Write down the second element, which is the second name. The prefix becomes a subscript. Okay. These do not have charges, so don't try and balance any charges. Okay. So let's try a couple. Oops. Carbon monoxide. C for carbon, no prefix, no subscript. Monoxide. Oxide is O. Mon means one, so no subscript. So carbon monoxide is just simply that. Dinitrogen tetroxide. Okay, nitrogen is N. There's two of them. Tetroxide, oxide is O, or oxygen. Tetra means four. Okay, now this is a molecule. Okay, you cannot reduce the formulas. This cannot become NO2. Okay, this is a specific molecule. It has two nitrogens, four oxygens in it. If you reduce the formula down to NO2, that's only one nitrogen, two oxygens. That's a different molecule. It also has a different name. This one would be called nitrogen dioxide. Okay, so you cannot change formulas of molecular compounds because dinitrogen tetroxide is not nitrogen dioxide. It's two different compounds. Okay, now, third class of compounds we can have. Okay, acids. There's a unique way to name acids. Okay, first of all, what's an acid? Acid is a molecular compound. It's a molecule. But when you dissolve it in water, it produces hydrogen ions. So it kind of acts like an ionic compound. Okay. Now, if the molecule is not dissolved in water, then you name it like it's an ionic compound. In other words, it's going to be hydrogen something. Okay. Even though it exists as a molecule. Okay. So, our example. Now, if it's dissolved in water, don't forget, this term here was called aqueous. Okay. And it's given the symbol AQ. That's what aqueous means. It's dissolved in water. That's all that aqueous means. Does not mean that the substance is an acid. It just means that it's in a solution. It's dissolved in water. So HCl gas. This is not dissolved in water. It's in the gas phase because that's not an AQ. So this would be called hydrogen chloride. Okay. Break it up and you name it like ions. Hydrogen ion and chloride ion. Okay, this one here. You break it up and you say, oops, there's hydrogen again. Okay, and there's NO2. NO2 was not on your list, but NO3 was on your list. This was nitrate. Okay, so one less oxygen means that must be nitrite. Okay, H2SO4. You see hydrogen again. Okay, and SO4, you've seen that one, is sulfate. Okay, now, once a substance is dissolved in water, it's aqueous. Now you name it as an acid. Okay, acids can be identified from the formula because you see H in front, and they have aqueous or AQ written at the end. So it'll be H something 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 AQ. Parentheses at the end. Okay, now follow these rules. These are the tricky ones. Okay, First of all, look at the formula, figure out the anion, and more importantly, what's the name of the anion. Okay. Anions will always end in one of these three endings: "ide", "ite", or "ate". Okay, so how you name the acid depends on the anion's name. So if it ends in "ide", you put hydro in front of that anion, change the "ide" to "ic", and then add the word acid to it. If the anion is an "ite" ion, like sulfite or nitrite, okay, then you change the "ite" to "us", keep the anion's name same, add the word acid to it. If it ends in "ate", "ate" becomes "ic", don't change the anion, and then add the word acid to it. Okay, so some examples here. This ion here was chloride. Okay, so since it ends in "ide", the rule was hydro in front of the anion's name, keep that base, chlor, and then "ide" becomes "ic", so hydrochloric. That's the part of the anion's name that you keep. Okay. The second one here, this one came from nitrite, so we have the "ite" ending. So nothing in front, keep the nite. Okay. "Ite" becomes "us", so it's nitrous acid, and SO4, your anion, was sulfate. Okay. The "ates" become an "ic". Now, we do not call this sulfic acid. Okay. It's not sulfic. On the sulfate, you add stuff to it. You add UR. Whoops. The 8 becomes "ic". Oh, let's rewrite that. It becomes sulfuric acid. Okay, so H2SO4, sulfuric acid. Okay, now, writing formulas for acids. This is the important part because you'll be given names. You need to be able to write out formulas. Okay, follow these rules. The basic rules for writing ionic formulas, ionic compounds. Okay, the cation is always going to be the H+. So don't forget, for ionic compounds, you have to take your ions, your first ion, X1+, combining with your anion, let's say it's Y2-. The charges don't cancel out, crisscross. Okay, so the cation is always going to be H+, even though it's not doesn't tell you what the cation is in the name. If it says acid, H+ is your cation. Okay, the name of the acid will tell you what the anion is. Okay, so work backwards. Okay, write down the formula. Okay, and balance the charges. Okay, and then the last thing, add aqueous to the end of it. Okay, so let's try some. Chlorous acid. This means us came from chlorite. Okay, now what's chlorite? Remember, chlorate was ClO3, 1-. Chlorite must be ClO2, 1-. Okay, so your ion, your cation must be H+. The anion is ClO2, 1-. Put them together. This is going to be HClO2. And don't forget, put in AQ at the end. Okay. Hydrocyanic acid. Hydro. Ic means it came from ide, which means your anion is cyanide. Okay. Cyanide is Cn, 1-, your polyatomic ion. H+ to start, so this should be HCnAQ. Okay. Phosphoric acid. Ic is the only thing that you worry about. Okay, nothing in front. So ic means it came from the 8. There is no phosphorate though. This part got added on. So the anion was phosphate. Okay, phosphate is PO4 3 minus, combining with H plus. You need 3 of these, so it's going to be H3 PO4 AQ. Okay. Hydrohydroxic acid. You see hydro and ic in front. That means it came from ide. So that means hydroxide. Okay. Hydroxide, OH minus, H plus. Combine these two together, HOH, AQ, which basically is H2O, AQ. So hydrohydroxic acid, water dissolved in water, which is water. Okay, now, before you can name or write formulas, you have to identify either your compound is either an acid, molecular, or ionic compound. Okay, so from the formula, how do you know if something's an acid, molecular, or ionic compound? Well, from the formula, if it's metal, nonmetal, it's ionic. Molecular must be nonmetal, nonmetal. And acids will start with H and in AQ, excluding these two compounds. H2OAQ is just water. H2O2 is hydrogen peroxide dissolved in water. This is not an acid. Okay, now from the name, which is the important part, because in the rest of the semester you'll be given names and you have to write formulas. So if you're given the name, the ionic compound's name, there's no prefix. Okay. The exception is if you see di in front of something, the last name. If you see di something, but it says dichromate, that does not mean it's molecular. It means you have the dichromate ion. Okay. Molecular compounds, the second name has a prefix. Okay. Acids, from the name, says acid. Okay, identify each of these as either ionic, molecular, or an acid, then write a name or formula for it. Okay, so try these and we'll go over them in class. Here's the review question. Classify this compound, carbon tetrachloride. Which group of compounds does it fall into? Ionic, acid, molecular, polar, or is that a formula unit?